Hello, and welcome to another episode of AppSec Decoded. I'm Taylor Armerding, security advocate for the Synopsys Software Integrity Group, and today we are pretty excited to be talking about the brand new Open Source Software and Risk Analysis Report, better known as OSSRA, OSSRA. This is the 7th edition of that report, and it was created by the Synopsys Cybersecurity Research Center, which also has its own acronym, CYRC. It is based on analysis of more than 2,400 commercial code bases, and joining me to talk about it is Tim Mackey, Principal Security Strategist within the Synopsys CERC, and he has played a key role in the OSSRA since its beginning 7 years ago. Tim, thanks for being here, and some things, of course, haven't changed a whole lot. Open source software remains in virtually every commercial code base that there is, and it's the large majority of every code base that there is. I think this year's report says 78%. But obviously, every year there are some things that change. And so, first of all, what do you think are the most compelling findings in the 2022 OSSRA report?
So thank you, Taylor. Thank you, everyone. The big thing this year was a couple things. One was the volume of code bases that we've analyzed went up by like almost double for practical purposes. That's a reflection of how popular the whole data source that's behind our report is, which is tech M&A. So people are buying companies and they want to make certain that everything is really good and it's going to meet their expectations from a technical perspective. And that's really important to think about with respect to the OSSRA report, because this isn't just a survey of somebody's view of open source. This is actual code where serious money was on the line. Last year was like $1.2 trillion of tech M&A that happened. So getting it right is part of kind of our methodology. So with that kind of as a backdrop, we've looked at trends over the years, and the report, I'm not going to rehash what's in the report. Go read the report. There's a lot of goodness in there. But from a trend perspective, one of the big things was an improvement in open source license compliance and an improvement in vulnerability management. So we saw fewer issues with respect to open source license compliance than we did last year. And we also saw an improvement on both high severity vulnerabilities as well as the average number of vulnerabilities that were in each code base. And that speaks to one of the realizations that has happened over the course of the last year, that open source powers the software supply chains that we all depend upon. We had President Biden's executive order saying software supply chains are a big deal. What powers software supply chains? That 78% number that you mentioned, Taylor. If you look at the average application out there, the foundational elements that allow for teams to innovate, those are open source in nature. You don't have to reinvent the wheel every single time as you would if you just kind of said, hey, I'm putting 4 walls around my software development team and they can't use anything that isn't already created by them.
Well, I think you pretty much dovetailed right into my next question. You mentioned some positive trends, and are there any others that you would mention besides the two?
So on the negative side of the equation, one of the big things that is kind of on the alarming side is the number of vulnerabilities that have been there year over year over year. I refer to those as foundational components, and they're somewhere deeper in the supply chain. So when you look at the decision process that a development team goes through, they're going to come up with, hey, these are our dependencies. And a dependency, you can think of it as a supplier. So here are the suppliers that I have. They fulfill this particular function, an encryption library, a file system, a WebSocket, or what have you. That's a decision that the teams are explicitly making. But when you have foundational elements, so a language framework or a paradigm that is implemented in a consistent way, that's something that is, quote, somebody else's problem, yet that's where the vulnerabilities that are persistent are coming from. jQuery is a perfect example of that. It was the framework that has the greatest number of vulnerabilities this year. And if you look at the top vulnerabilities that came out in terms of impact, jQuery was unfortunately well represented there. And some of the vulnerabilities in question have actually been there for years.
As we said, open source is not only popular, but it's pervasive. And why do you think it's so popular? Tell us why it's so popular, and what are the benefits and the risks? Obviously, it's good. There's some good things, and there's some things that are risky. What are those?
So one of the things when people start talking about open source and risk, they inevitably gravitate towards somehow open source is quote-unquote bad. And open source is no more or less risky in that respect than any commercial piece of software. What's different is the methodology in which you access the code. If you go to a proprietary software vendor, you don't necessarily have the ability to say, is the code doing this versus that. You have to trust that they've got adequate testing in place. With open source, you can actually go and verify that they've got adequate testing, that they've gone and done the design that you would expect to do, and the functionality is as you would expect. Where the risks really come in are on the management side of things. So if someone just downloads a component from the internet and they don't have a process to go and find out whether or not they're pulling that component from an approved location or an official location, or have a mechanism in place to keep it up to date whenever there's a new update issued, then they're just accepting a whole pile of risk because they don't necessarily have a process to go and patch things if things go awry. And that's one of the big reflections that we saw with respect to the whole Log4j experience at the end of last year. This was a foundational component, the thing that goes and does logging in Java applications, that in reality, most organizations never thought of, never realized until they had to go and figure out what their process would be, kind of with a gun to their head.
As you mentioned earlier, there were some trends that were a little bit discouraging. And one of those is that in some cases, the OSSRA report found that in some cases, the percentage of a given vulnerability in code bases remained constant or even increased year over year. Why do you think DevSecOps teams are struggling to stay on top of known, not 0 days, but known open source risks?
So it's really a question of known versus knowable. And so before I mentioned about the decision-making process around suppliers, if you start to take a look at how many organizations are actually doing the work of verifying what their supply chain looks like, that's a pretty small number. So in addition to our OSSRA report, we also put out a BSIM report, and last year's BSIM data said that, well, less than half of the organizations weren't even getting to the point of understanding what their next level dependencies were and what the overall risk one layer down or 2 layers down are. And that's really the core challenge when you start talking about something like a Log4j. You go buy the top level thing, or you go and make the decision around that top level thing. Log4j is like 5 or 6 levels deep. That's well and truly in the realm of that's somebody else's problem to solve. And there's an implicit assumption that is unfortunately a fallacy in the land of open source. There is no vendor known as open source. There is no situation where the person who's creating the project has a product manager who's going to receive your requests and go and run a roadmap with you and go and talk about what the next 3 years of feature development are. They're working on this as a project that is beneficial to them, not as a commercial entity. So organizations that have embraced a DevSecOps paradigm, or even more traditional InfoSec and ITLM, or ITIL rather, paradigms, well, they've got an implicit assumption that I'm dealing with a supplier that is a commercial software vendor and will push updates out to me, will notify me proactively. In open source, if you just download it for free, nobody knows who you are. Nobody knows why you did it. Nobody knows how you're using that component, so there's no possible way for them to go and say, hey, you know what, there's this really super critical vulnerability that you need to patch. Here's the patch. We're really good guys over here doing this. That communication flow simply does not exist. And the net result is you end up with these persistent vulnerabilities that are in a foundational layer people just didn't know about.
Right, right. It's not like when I look at my phone in the morning and I see that I have 3 updates that got pushed out to my phone. Yep. Not like that.
Not like that at all. The marketplace for your phone knows that you have this app, so there is a push mechanism that's there. But if there's an app provider who's not, for example, updating their app as a result of an open source vulnerability in a library that they're using, there's no push. You wouldn't know, and they don't know, and therein lies the problem with these persistent vulnerabilities.
Right. Open source software security has got the attention of governments. As we all know now, President Biden issued an executive order almost a year ago. We're coming up on a year, May 12th of 2021, on improving cybersecurity in the United States. And there are similar initiatives in other countries and regions. Plus, there's guidance from government agencies like the FDA, automotive via Open Chain, and others. What do you think that says, and should it say, about what a government's role is or should be in relation to open source security?
So that's a really, really important question. And I've been kind of running around for call it the last 6 months, 8 months or so, with the phrase, can President Biden force us to fix our software? And in reality, he can and he can't. So government goes and sets a set of standards and guidance around how they procure software. NIST, NTIA, ITI, and a variety of other entities are all feeding information into the government about, well, this is what the real world looks like. This is how we go about doing things. This is the guidance that you guys should be emitting as part of this overall effort. And so how do I fix my software? Well, fix is, of course, a subjective term, but as we get closer to that 1 year date, one of the things that's going to happen is that there's going to actually be acquisition requirements that are going to come from the federal government that will be imposed upon the various government agencies, and you'll start to see an uptick in what it means to quote-unquote comply with the executive order. Nobody knows exactly what that looks like today as we're recording this, but in about a month and a half, we'll have a better understanding. That might mean that you can't ship software that has any known vulnerabilities in it. Possible. That might mean that you have to communicate the test results for your software to anyone who is acquiring software through the US government. Possible. That might mean that you have to attest to the components that are inside of your software through a software bill of materials. Very, very likely. And there are all different types of nuance that is part of the executive order because it is very, very far reaching. The net result is, it's not just hey, I'm selling to the US government, it's who's selling through and to the US government. So my canonical example is, think of the Veterans Administration. They run hospitals. There's lots of software in hospitals. There's lots of medical devices in hospitals. Those medical devices all have software in them. There's ambulances that are going to take you to the VA hospitals. There's all of the logistics around that, all of the human management from an HR system. All of those are pieces of software that ultimately are being procured either directly by the Veterans Administration or provided through to the Veterans Administration. They're going to need to have a level of compliance with whatever that executive order looks like. So what we see in the OSSRA report around open source governance is going to be reflected in the requirements that we'll start to see emerging in the next couple of months.
We're going to leave it there for now, but we'll be talking in more detail about the OSSRA in the next edition of AppSec Decoded. Thank you for watching. I've been talking with Tim Mackey. I'm Taylor Armerding, security advocate for the Synopsys Software Integrity Group, where we help organizations build trust into their software.